Dear students, the next very important concept, and this is very important to understand, is how to convert a non-terminating recurring decimal in P upon Q form. What we have to understand is, we understood that when we are converting rational numbers into decimals, they are coming as either terminating or non-terminating but recurring decimals. Suppose we have a number 0.666, it is repeated infinite times. First thing is, we represent this as 0.6 and a bar is there above the 6 to represent that 6 is repeated many times. How we are going to convert this 0.6 bar into a form of P upon Q, which is the standard form of the rational numbers? What we'll do, we'll first of all write let x be in P upon Q form equivalent to 0.666 repeated. That means what? We can write this as x equals 0.666 repeated. Now if we are going to multiply 10 on both sides, what shall we get? Multiplying x with 10, we get 10x. Multiplying 0.66, we get 6.66 repeated infinite times. Why we are multiplying with 10? Because a single number, decimal 6, has been repeated. Only 6 has been repeated after the decimal. So we have multiplied it with 10. Right? Let us give these equations the number 1, equation number 1 and equation number 2. What we are going to do? We are going to subtract equation 1 from 2. That means we'll write equation number 2 at the top. That was 10x equals 6.66 repeated infinite times. In the bottom we'll write the first equation 0.666 repeated many times. When we are subtracting the right hand side, what we see is all these infinite repeated 6's, they become 0 after the decimal place. Before the decimal place, what we get is 6 minus 0 is 6. So all these repeated 6's, because they are infinite in number, they will all subtract out to become 0 infinite times. When we are subtracting the left hand side, what we get is 10x minus x is 9x. The value for x we can find as 6 divided by 9. If we divide both of them with 3, we get 3 to us 6 and 3 3 us 9. So 2 upon 3 is the P upon Q form representation of the rational number 0.666 repeated many times. Let us see one more example for this. If we are given another number, that is suppose 0.47, and now only bar is there above 7 or only 7 is repeated. But before that, there is a number 4 also. So we have decimal 47777 if 7 is repeated. What we'll do, we can directly take, let x equals 0.4777 repeated. We mentioned this as equation 1. Now what we'll do, we'll multiply it with 10 because only single digit is repeated. So we multiply equation 1 by 10 on both sides. When we are doing so, what we get is 10x equals x multiplied with 10 will be 10x. 0.47 repeated will give us 4.7777 repeated many times. Let us mark this as equation 2. As usual, as we had subtracted the two equations, we will again subtract equation 1 from equation 2. Subtracting equation 1 from second. So we'll write 10x equals 4.777 repeated. X equals 0.4777 repeated. The only difference that comes over here is these all 7s will be subtracted to 0. When we subtract 7 minus 4, it will be 3. We subtract 4 minus 0, we will get 4. Here we are getting is 9x. So we can find the value of x by dividing with 9, 4.3. Now there is one decimal part. We can remove this decimal by putting a 0 along with 9. So that will be 43 upon 90 as the decimal representation of 0.477, where 7 is repeated many times. One more example where we are given the number maybe 0.63 and this time 63, both the digits are repeated. Now we have another number where both the digits, two digits are being repeated. Till now we had seen examples where only a single digit was repeated. This time we are taking an example where a set of two digits are being repeated. We'll apply the same procedure with a only minor difference. We'll take up this x as 0.636363 repeated. This time what we'll do, we'll not multiply with 10, but we'll multiply by 100. Why we are multiplying by 100? Because two digits are being repeated. So both these digits we want to have before the decimal. So we multiply equation 1 by 100. What we get this time is 100x equals 63.6363 repeated many times. This be equation number 2. Now the same process we will adopt. We will subtract equation second from first. What we'll have is 100x on the left hand side, 63.636363 on the right hand side. Then first equation x equals 0.636363. They will be subtracted. What we are going to get is this side we get all the zeros after the decimal. We get 63 only before the decimal. 100 minus 1 is 99x. So what we can do, we can find the value of x as 63 upon 99. Now as we told you, the rational numbers in standard form are when they are in lowest terms. So what we'll do, we'll divide them with 3. We'll get 21 upon 33. We are again able to divide them by 3. We'll get 7 upon 11. And if you represent 7 upon 11 in decimal form, you will be getting 0.636363 repeated many times. I am sure this is clear to you.